Okay, so we're going to do just some quick demos of query parameters for your REST APIs. Talk about query parameters versus path parameters. And then we're going to do some MongoDB filtering based on those query parameters. And then we're going to use some regex and talk about that really quick. So let's jump into our continuous demo, which I will link for anyone in the chat who's interested. And I will do not disturb my phone so that I am in fact not disturbed. Cool. All right. Let's jump in to our ice cream shop. Last week, what we ended up doing, oop, I'm gonna share my whole screen. Cool. Last week, what we ended up doing is we use Postman to create this new patch endpoint where we can add to our inventory. And then we also put our inventory on MongoDB. So I have an application called MongoDB Compass, which I'm going to go ahead and open. And in MongoDB Compass, we can connect to our locally running database, which I have installed and running just locally on my machine. And we have this database down here with this ice creams collection, and we have a bunch of different documents of ice cream. So we have our flavor, we have our scoops, so on and so forth. And then we wrote an API where we can submit new ice creams. Maybe we have vanilla, 10 scoops. Oops, we gotta run our thing first. All right, our server running. And now we can add some vanilla, we can add some chocolate. And if we get to our stock, we'll see that we have those 10 vanilla and 15 chocolate we just added, and those should show up in MongoDB. Cool. So what we have right now is we have a single get endpoint, which if I go ahead and open my ice cream shop, I can see this controllers file. Oh, we have this get stock function. So when I go into my Postman and I issue my get request to my ice cream stock URL, then that goes into our routes. And we have our get/stock route, which just calls get stock. And we issue this find statement. So find is the way that we do a query to MongoDB in order to find some amount of documents. We actually kind of already used query filters in the previous lesson, but we'll talk about them again. But by default, find is going to look in this collection of all of these ice cream documents that follow this model, and it's going to return all of them, which is generally not always what we want. Sometimes we want to find one specific ice cream. In this case, we want to find the ice cream that has a flavor that matches. In other cases, we might want to find all of our ice cream where we have at least 10 scoops left. If someone were coming in and say, I want to buy like a gallon or a quart of ice cream, a gallon is a lot, a quart of ice cream, and I think that's 10 scoops, well, they're not going to be able to buy that unless we have enough. And so we would want to use some sort of filtering in order to only get the ice cream that have at least 10 scoops left. So it's very useful to be able to restrict these filter expressions. Very common practice. And we also need some way in order to communicate to our API what the user wants to filter. So with this endpoint, I can check everything that I have, all of my ice creams. But I don't really have any control over what I get back. In this particular example where I have four flavors, not really a big deal. I can just visually browse through these and generally figure out what I need. But usually your data is going to be much, much larger than just four documents. Um, Maybe an ice cream shop isn't a great analogy because you're not going to have millions of different flavors of ice cream. But something like buying a product on Amazon. When you search for a product on Amazon, if it returned every single product to display to you, that would be a bit of a nightmare. You'd have millions and millions of products. Your page would be really slow trying to load them all up. And so generally, when you create a GET API like this, you want to be able to specify filters when I'm calling the API in order to restrict what I'm getting back. So that's maybe Amazon saying, give me all of the products that match the text that someone searched for. So anything that contains the word shelf, maybe, and then you show all these different shelving appliances. Um, Maybe I want to sort my data, in which case I would specify in my API call, sort all of the responses alphabetically in descending order, and then give me those results. Generally, your backend is going to be a lot more equipped to handle this, especially the database system that you're using. Oftentimes will be able to handle this for you without you having to write any code or do something really inefficient. And so we need some way in order to pass those parameters to our URL, parse those, turn them into MongoDB statements, which is something that you guys are going to do for your assignment this week. So with that said, let's figure out, I'm so sorry. Let's figure out what parameters we're going to accept. So what would be a useful parameter given our MongoDB data in its current state? We only have a flavor and a number of scoops. What interesting filters might we be interested in or sorting? Any suggestions? Maybe as a starting point. Oop, max to min scoops in the inventory. Yeah, that would be great. That way we can tell how much ice cream we have and we could reverse it and say, these are the ones that are running out. You should refill these ones first. Sort. We could sort by min and max, or maybe this is what you were um, saying. So correct me if I'm wrong. Maybe we also want to say only give me results between two numbers. Only results between sub and max. So if I say give me uh all of the ice creams that have between 0 and 10 scoops, and I want to check all the ones that are very close to being empty and when I need to refill, then I could use something like this. That would also be useful. Probably also want to match based on the ice cream name. So I want to say only give me ice creams that match chocolate something, mint chocolate chip or regular chocolate. We're going to use regular expressions for that. Maybe we can start here. Um, and then let's implement a couple of these and make sure they work, and then we'll go from there. So let's start with our sort, just to pick one. So first we're going to sort our ice cream. What should people be able to sort by? They should be able to sort by flavor or by scoops in ascending order or descending order. Let's go ahead and implement this. So what does this actually look like? How would I pass these parameters? Well, there's two ways that we can pass parameters. We can pass them as query parameters. Query parameter would be, I have my URL here, API ice cream / stock. A query parameter goes on the end of your path to a specific REST API endpoint. And we're going to use a question mark to indicate that the rest of this is all query parameters. And then we're going to give it a bunch of key value pairs. Foo equals bar. Baz equals foo bar baz. I don't know. This is one query parameter. It has a key and a value. And we can have multiple query parameters by joining it with an ampersand, another key and another value. These can be anything you want, whatever data you think is useful to take into your API. For sorting, maybe what we do is we say sort by equals some key and sort order is equal to either ascending or descending. Doesn't matter which one, but it has to be one of those two things. These are some query parameters that we could take in. Why are we putting them like this? Well, a query parameter is something that gets stuck onto a get in order to restrict the number of things that you're getting. So anytime you have a get endpoint that's going to return a bunch of data and you want to specify a specific piece of data that you're returning or a subset of data that shares something. Is that someone speaking? Oops, maybe not. All right. Well, anytime you want to restrict the amount of data, that's generally when we want to use a query parameter. There's another type of parameter too that also will typically go with, well, it can go with get endpoints and it can go with other things as well. Let's say we have ice cream / stock / ID. You might see this pretty often with this colon in the path. This indicates that there is a chunk of the path here, but it is a variable value. So I could query to query with ID number 1, ID number 3, ID number 7. All of these are totally valid. And they will all match the specific route that exists and is defined with this path. And we can read in the value that was inserted for this particular path parameter, which is this 1 or this 3 or this 7. Typically, we use these things when you are identifying a resource that exists on your server. So in this case, maybe the ID of our ice cream. MongoDB by default sticks in this object ID. Maybe we had like a separate field that was a number and started with 0, and every time I insert something new, it increases in value. That might be something we could put here. Anything that uniquely identifies our object. And this, when we use a parameter like this is usually indicating I want a specific resource, only one that matches this. Whereas these query parameters are for restricting to a subset of data. You could use a query parameter to also select a very specific piece of data, but usually these are in conjunction with something that's going to return a lot of results. Path parameters we generally can use on get endpoints, or if we wanted to post a new ice cream flavor, we could modify that API to take in an ID here. And whatever that ID is, then we would post a new ice cream to it. This is maybe not a great example. Maybe we have some other stuff down here where we're adding a new carton to this ice cream flavor that has ID equal to this. So these path parameters you'll see in lots of different endpoints. Query parameters are generally reserved for gets. All right, enough lollygagging. Let's do this thing. So we can get query parameters from our request dot query dot and then the name of the parameter. So we said that we're going to call this sort by and sort order. Let's use some object destructuring here. All right, so this is how we're going to sort. And maybe we pass these parameters to our getStock function. Sort by, sort order. If I were to not pass these query parameters, then these will both be undefined, which we're going to handle very specifically in a second here. So we have our sort by, we have our sort order. So let's start by saying we have some filter expression, and this is an empty object. So by default, there are no filters. And in MongoDB, every time that we add a key and a value, it's going to add those filter expressions. So what do we need to do here? If we have MongoDB, we can use this $ syntax. I don't actually know if there's a sort. I should have checked this before we started. There's got to be a way to sort with MongoDB. All right. I think that we want to instead sort using the result of this expression. So here's what we're going to do. We're going to say let's get rid of this filter expression. Sort expression is equal to nothing. We are not going to sort by default. And if sort by exists, meaning it's not undefined, and then this will return true. You could also like be really explicit here, but we're just going to leave it as if sort by is true. This goes to the concept of truthy and falsy variables and values. So if this is defined, then our sort expression is going to be sort by, and the value is our sort order. So the sort order we said is either going to be ascending or descending, and our sort by is some key. But we probably shouldn't let them pass any values they want, or else we're going to open ourselves up to some security problems where someone could pass in some dangerous values, and that MongoDB query is going to do something bad, like delete a bunch of data or give it back to the user when it shouldn't. So let's create some constants up here. Valid keys for our ice cream model is flavor. And scoops. Valid sort orderings. Actually, we don't need constant for that. Let's check to make sure that these are okay pieces of data before we go any further. So if valid keys dot contains index of is what we use sort by. So if whatever this field is appears in valid keys, actually we'll check if it's not in there, in which case the index returns -1 if it's not present. Then we're going to return invalid key for sorting sort by. And if sort order is not ascending or descending, so it has to be one of those two things, we're going to return invalid sort ordering. Sort order and sort by. All right, so now we have our sort expression. If we know that it's a valid field and they've provided a correct value, then we're going to set our sort expression and we can sort by that sort expression here. So the problem here with JavaScript in general is that for some reason, JavaScript allows you to sometimes return one value and sometimes return something totally different. So instead of doing this, what we're going to try is we're going to throw an error, which is to say that it will cause an error that has to be caught. So this is not going to explicitly return a value, rather it's going to just like totally explode the function and throw an error. And our filter here, we should not do this. We're going to find and then sort. One thing you'll notice in the instructions for this week's assignment is that they talk about the concept of throwables in Mongoose, where you can chain operations onto the query like sort, and only once you then call await does it execute this full query, which does the find and the sort and gives you back the results. So I could assign this to a value, query is equal to, and then return await query. This also works. It's just unnecessary. So we're going to return the result of executing this. And where this gets called in our route, we now need to explicitly catch this error. So we're going to try to get the stock using these parameters. And if it's successful, then we're going to return with a status of 200. Otherwise, we're going to catch the error and res.status 400. And we'll spit back that error. Let's try this out on Postman, see what it does. I'm going to restart this just in case. And now we have our get expression. So I can not put any sorting on it. That's totally fine. Or I can now do sort by foobar And that will give us an error. But that didn't work. So let's try and figure out why that didn't work. We should be getting a message here. Invalid key for sorting foobar. Okay, but that's what I want. Lots of opinions about how to do error handling. So what are we missing here? So what do I need to call here? E.message is what I want here. Because this is a full object, but I really just want to return the string. E.message. Let's try this. Oops, not E. All right, that looks better. Invalid key for sorting foobar. Foobar is not a field, but I can sort by flavor. And if I do this, my sort ordering is not defined, which is bad. In which case I can sort in ascending order. This does not look like it actually worked. Definitely did not work. All right, now we're going to figure out why it didn't work. Sort by descending. Oh, that's the problem. This, I'm trying to use the value as a property of this object. But you can't do that. So when I just put sort by here, it's putting the key as the literal string sort by. So instead, what we're going to do is we're going to say sort expression and then use square brackets. This, and we then do it again, is actually going to work because it's going to now take the value of this variable and try and access the property at that specific key of the object. So now if I go in here and I'm sorting in ascending order, or descending order by flavor. It's going to start with the alphabetically latest one. V is at the end of the alphabet, and C is at the beginning. We can flip this around really easily too. Chocolate, mint chocolate chip, strawberry, vanilla. We could also do scoops in ascending order or in descending order. So that's pretty cool. And now someone who's using our API can flexibly do whatever they need with this API. We're not making any assumptions about what they want to do. We're just providing them with the toolkit in order to be able to accomplish their goals. And so we could use this API from our application in a lot of different ways if we wanted to. All right. So we have our query parameters, we have our MongoDB filters and our sorting filters. Let's briefly cover regular expressions and see how we could use one of those here. I'm going to go to a site that I really like called regexer. There's so many different sites that help you test out your regular expressions. But essentially, a regular expression is just a pattern that you are trying to match to any string. That you're testing this regular expression pattern against a string to determine whether that pattern exists in the string or not. So my pattern could be literally just a bunch of characters. So does my string contain the word foo? It does not right now, but then if I type foo in here, now it does match. We could test it against a bunch of different strings. Oops. And so any string that has foo somewhere in it, that pattern exists in the string, is going to match. Anything that doesn't is not going to match. But we can also do some really powerful things like everything described in this cheat sheet, which I reference very often. We can match any character. This is a wild card. So every single string now matches because every single one has at least one character. If I took everything out and it was an empty string, then it wouldn't match. But I could say, I want exactly, no, that's not what I want. We can specify quantifiers to say how many of these things do I want? Well, I want something that is between 1 and 5 characters. So this is bad. So this one would say I want at least 5 of any character. So anything that has less than 5 characters is not going to match. Anything that has 5 or more is going to match. We can also specify these anchors at the beginning and the end to say match starting from the beginning of the string or the end of the string or both. If you specify both, then you're saying my whole string needs to match this pattern, which I could do here and say my pattern is only going to be made out of alphabetic characters. So if I have 0 or more, we're going to use this star. And so now my pattern is saying from the start to the end, so matching the entire pattern, you can match any character in this set. So anything from A to Z, uppercase or lowercase, we're going to match it 0 or more times. If I were to type in something here that has a number or a special character, then it is no longer a match because we have more than just the characters in this set. So the amount of matching that you can do with a regular expression is limited by your imagination. People use regular expressions very often. I end up using regular expressions when I teach the React course in order to demonstrate how I might create like a login form that validates that someone's password matches a bunch of arbitrary restrictions. We can specify a regular expression that fits all of those restrictions to say this regular expression enforces the password has to be at least 8 characters. It has to have letters and numbers, so on and so forth. That's something that would be really hard to code up from scratch ourselves, but it's pretty trivial with a regular expression. This is a great toolkit item to have. You'll use it in your career many times, not like every single day, but it's a very common thing to have. Um, Generally, we try and use regular expressions for things that would be really complicated to code up by hand, but at a certain point, if your regular expression is a bajillion different, really complicated things, then you're not really helping anyone. Um, and maybe you should just, write some code by hand to do whatever you're trying to do. So what are we going to do with this? Well, what I would like to do is I would like to specify a regular expression for our route that is going to filter based on the flavor as a regular expression. So I can specify, maybe I have my base route here and we're not going to sort, although we certainly can. But I want to filter by name, matches, and then I give some regular expression. So maybe I say it has chocolate. Yeah, that's what we'll do. We'll say the name matches chocolate, and this pattern can appear anywhere. It doesn't have to be the entire name, but it just has to appear somewhere just to make things easy. This is a regular expression, even though it's just a string. Since there are special characters in regex that do powerful things like we saw in this cheat sheet, but otherwise, like your numbers and your characters without those special characters, they literally just match exactly what you want. So if this pattern appears anywhere in the name, then we are going to return it. So how would we do that? It's a great question. We're maybe going to have to consult Google on this a little bit. I haven't done this in JavaScript in a while. But we are going to get started how we know name matches. I'm curious whether we can destructure it using an underscore or not, given that the parameter has an underscore. So I'm going to test this hypothesis. Oh, it does work. All right, so we have this parameter name matches equals foobar. And then over here, when we print it out, that's exactly what it is. All right, so we can destructure it like that as well. So let's pass this to our function as well. And we'll add this parameter. So we have our sort expression. And let's create a filter expression, which is going to be empty by default, which is to say, give me everything. It's the same as doing this. And if name matches exists, so if we passed a value for it, then we're going to let's Google this really quick. I think if I were to do this in MongoDB Compass, I would specify the key flavor, and then I would use these these slashes, which is actually the same syntax as in JavaScript, to indicate that I'm creating a regular expression pattern, and chocolate. And that will only return me things that have chocolate somewhere in the flavor. Note, if I just did a string, then that would not work because only this one has an exact match chocolate. But a regular expression can appear anywhere as long as we don't use those anchors. And so it will also match this one, which is what we want. So I'm curious, we might be able to just do this. And then we'll put our filter expression in here. We're going to see if this works. So this creates an object where the key is name and then the value is a regular expression where it is a pattern that is whatever I put in that key. And we're going to run it and see what happens. Name matches foobar. Nothing matches foobar. Chocolate. That didn't work. Let's check our filter expression just to see what it does. And I try and send this. Name is regex chocolate. Mongoose. Regex. All right. I think we're gonna have to use this syntax where we have a like a directive in MongoDB. I don't know if anyone's played around with SQL, but a lot of the stuff that SQL does in a really nice syntax that everyone knows, you have to do with these like crazy directives in MongoDB, which is a little bit annoying. So I think what we actually need to do here instead, since this syntax doesn't work, is we need to say our name is another object where regexp, no, just regex. And here we can put that new regexp name matches. So now if I were to do this again, I send my query, that still doesn't work. Name. Oh, it's not name, it's flavor. We don't have a name property in here. We have a flavor property. All right, this one works as expected. So now it's doing the regex on this flavor. Anything that matches chocolate or vanilla, it's going to match vanilla. I can do some more complicated stuff like anything that has at least 5 characters, or let's do 10 characters. Split the difference with 8. We're going to consult the dictionary here. Okay. Oh, we want that dot to indicate that anything can happen 8 or more times. So now only the ones that have at least 8 characters are going to show up. We don't have vanilla, but if we were to say anything up until 8, this is, I forgot, this doesn't work because we're matching any part rather than the whole string. But our initial things did work, which says at least 8 characters of any kind, which filters out vanilla, and we could increase if we wanted to 12. I'm going to go back really quick and see if my original syntax actually works now that we realized that it should be flavor instead. I really have a feeling that this is going to work. Yeah, okay, so this does work too. Well, we probably should change it from name because that's not a real property. Flavor matches instead. And so now if I search for name matches, that doesn't do anything. But if I were to search for flavor, then that works. Cool. We have our regular expression working. And we can use this on strings. Regular expressions are for strings. Doesn't really make any sense to apply a regular expression to a number. You can just use some math. All right. I said we were going to be quick, but we were not. But this is all that I really want to talk about, just to put some ideas in your head for this week's assignment. You're going to have to do some more extensive filtering and sorting. Feel free to use, this example and just, knowledge about these concepts in order to apply them in your own way. You can reference this however you want. I'm going to upload the code for this example before the end of the night. So feel free to reference as needed. That's all I got. I'll stick around for a little while for questions if there are any. Otherwise, make sure to sign in before you leave. And I will not be having a session next week because I will be out of town. I will post a reminder for that. So I will see you guys 2 weeks from now.